right, so after a couple days of solving exponential equations, which can get kind of tricky, I'm sure you're ready to do something else. What we're going to go through is try to find an easier way of solving these equations. So we're going to talk about, finally, logarithms and how they are just inverses of exponents. All right, so this is the form that we're really used to. We know that 4 squared is equal to 16. 4 to the 1/2 is equal to 2. All right, this is the one that we were working through on our first day of these. So if I take this exponential equation, logs are just the inverses. This is a familiar word to you. All right, if our original function was something where my input was 2 and my output was 16, when we're talking about the inverse, remember all an inverse does is we take x and y and we switch them. So the inverse of input 2, output 16, that inverse would be when we input 16, our output is 2. Logs are exactly what that's happening. So if I look at this one right here, we know that 4 to the second is 16. And if I look at my logarithm, it's log, so it will really have the word log in it for logarithm. Base 4 of 16 is equal to 2. So here's what happens when I want to go between the forms, and that's all we're going to focus on today, is being able to go from exponential form into logarithmic form, and from logarithmic form into exponential form. All right, so you're familiar with bases with exponential. We know that we call that thing right there. The reason that I'm always using the letter B is because that's the base of our exponent. That is going to be the same thing that happens when we rewrite these two on the same horizontal, are the same equation, just written in different forms. When we rewrite it in log form, that is the base of the log. All right, the other thing that happens when we rewrite it, we're switching x and y. So when we look at x here, it was the exponent. Now it's our output. It's what our equation is equal to. And then instead of equaling y, we're taking log base b of y. So let's look at some numbers. We all know that 4 to the second is 16. So if I rewrite this in logarithmic form, log base 4 of 16 is equal to 2. So again, the base here is the base there. But then notice what happens with the 2 and the 16. The 2 and the 16 are going to switch places because that's the act of switching the x and y because they are inverses. All right, if we look at another one, 4 to the 1/2 is equal to 2. So again, all of these are base 4 because I'm using the same one from the first day. So log base 4 of 2 is equal to 1/2. So again, these two things are just switching places. All right, and then if we put it with 2 letters here, again, still base 4, log base 4 of y is equal to x, if we know that 4 to the x power is equal to y. All right, so again, all we're going to focus on today is going from one form to the other. We'll get to evaluating here in a couple days. So common logarithms. There are some things that are more common than others. These are going to be what you see the word common log, that means that they are base 10. And that is a log that your calculator can do easily. And we'll show you that in a few lessons. So instead of, we could write it log base 10, that becomes a superscript, a smaller number. All right, so log base 10 is a common logarithm. And because we use it so often, we often for base 10 just write log and we don't put 10. So we've done this before this year. You guys know that that is a square root. You also know that we can write square root like this. So if we just see a log without a base, that implies, just like there's an implied 2 right here, that implies if there's no base, it's what we call the common logarithm, and that base is equal to 10. All right, so no base equals base 10. Another thing is a natural logarithm. And a natural logarithm instead of being base 10 is base E, where E is Euler's number that we learned about before spring break, that 2.718, and it keeps going forever and ever. It's like pi, it's a constant, a base E log. So a natural logarithm, we could write it as log base E, but another way to write that is just using ln for natural log. It's kind of backwards. Think about the L for log and the N for natural. So those are two. Similar to what we do with the radicals and square roots. We know that one's a square root. We don't need the 2 in the index. If we just have log, it's base 10. And if we have ln, that's a natural log. So again, our goal today is to go between the forms. So we're going to look at a few examples of each type, and then you have some practice problems to do. So for number 1, it says write each equation in logarithmic form. So if I have, and it's helpful, especially right now because we're learning this, to think about, let's think about if we have b to the x power is equal to y, then what the inverse is, that logarithmic form, is log base b of y is equal to x. All right, so when we're looking at here, my base is 3. So when I write this, it's going to be log base 3. All right, we're going to have an equal sign, but then again, because they're inverses, we flip the x and the y. So the 4 is by itself on the other side of the equal sign, and the 81 is, all right, and if once I show you tomorrow how to evaluate these, it will make sense that the log base 3 of 81 is equal to 4 because 3 to the 4th power is 81. All right, if we look at letter B, okay, we're going to do the same thing. The base is the commonality. The base of this is the base of the logarithm. So when I'm writing this one, I'm going to write log base 4, and then the other two switch. So here I'm going to put 1/64th. And on the other side of the equation, I'm going to put -3. So again, we're just changing the forms. And right now it's probably going to seem super not helpful. But as we get to doing more of this stuff, I promise it's going to be helpful if we can transfer back and forth between the forms of equations. All right, for C, we can write this 2 ways. All right, the base is 10. So I can write it, and there's nothing wrong with writing it this way, log base 10 of, now we switch sides, of 100 is equal to 2. But base 10 is the common log that we were just talking about. So I could also just write this as the log of 100 is equal to 2, because when I don't write the 10 for the base, that is implied. So either of those two are fine for letter C. You just have to be able to identify that they both mean the same thing, for instance, if it was a multiple choice question. All right, last one to go through here, we've got e to the 0 power equals 1. And we know that's true, right? Any number to the 0 power. So we're just going to rewrite this in log form. So I could do log base e of 1 is equal to 0. Or this is a natural log. I could also write this as the ln of 1 is equal to 0. All right, so our big idea for today is just changing around the form, getting used to reading that log. All right, and then we'll start evaluating them and using different properties of them and go back to those equations that we were solving for the last 3 days. We're going to do one more set of example problems, but we're going the other direction. So our directions on this, we're going from log form to exponential form. So we're starting with log base b of something is equal to something else. And we're going to rewrite that as our base to the x power is equal to y. All right, so for letter A, it says log base 5 of 125 is equal to 3. All right, so again, tomorrow we're going to work on, like, maybe you won't have the equal 3 and you have to figure that out. All right, today we have it, and hopefully we can make some sense of that as well. I'm just changing the form, so my base stays the same. It's 5 to the third power is equal to 125. So let's think about this. If I multiply 5 by itself 3 times, 5 times 5 is 25, multiply by 5 one more time, it's absolutely going to give me 125. So these are both true statements. All right, when I do this second one, log base 2 of 1/2 is equal to -1. So when I'm rewriting this, it's going to be 2 to the negative first power is equal to 1/2. And let's think about this, because again, these transitions might make you can kind of check in your brain. Another way to write 2 to the negative first power is 1 over 2 to the positive first. Right? This is a true statement. This is a true equation. 2 to the negative first is equal to 1/2. All right, we're going from log, there's not a number there, the log of 1,000 equals 3. So remember, there's not a number there. It is a 10. Okay, so we need to remember that that 10 is there. So this is going to be 10 to the third power is equal to 1,000. Again, let's think about this. 10 times 10 times 10 would definitely be 1,000. All right, our last one for today's video. We have ln of x is equal to 5. So what we want to think about, this is our natural log. This is the same thing as log base e of x is equal to 5. So now we're going to turn that in to exponential form. So the base to the e to the 5th power is going to be equal to x. All right, so please go to Canvas and try the practice for today. And we'll be in conferences if you have any questions.